you please speak a
Just
bit louder?
give me 5 minutes to settle.
Hello, ma'am. Am I audible? Hello.
Yes, you're audible.
May I have some doubts?
Yeah, so your doubt is regarding what? Because what's your doubt?
Regarding some questions, ma'am.
From week one?
Yes, ma'am. One week one.
Yeah, so what we will do is cover the theory of week two, and then we will take the doubts. I hope that will.
Ma'am,
Ma'am,
can you
you're not
repeat?
audible. You're not audible.
Voice was
I'm
not
not
audible.
audible. Hello, I'm audible now.
Ma'am,
Yeah, now you're audible.
Yes, ma'am.
can you repeat?
Yeah, so I was saying that first of all, we will cover the theory of week two, and then we will start week one doubts. Okay.
Okay, ma'am.
Okay.
Can we start with functions?
Yeah, I'll start with functions only
Ma'am, can
because
you please explain the set once again?
no, I won't explain the set once again. If you want, you can go and check. Because see, if I start with set, then I have to go for relations and then I have to go for functions. So it's like a repeating a class. So you can go and check the previous lecture. Okay.
Excuse me, ma'am. Excuse me, ma'am.
Yes.
Ma'am, I am unable to join that announcement group because it is showing that content unavailable. So how I can work with it?
You have to mail the support team because they only solve your problems. We don't have any access to any of the things. So I don't think how can I solve your. So I'll say that just uh, mail to support team. If they won't respond, then let me know in the next session and give me your email ID. I'll pass your email ID to them so that they will contact you.
Okay, ma'am. Thank
Okay.
you.
At the end, I'll ask for all the email IDs. Then you guys can. Tell.
Yes,
Okay,
ma'am.
is that okay?
Yes, ma'am.
Fine. So I hope my screen is visible. So I'll start the class, and after the theory, you guys can tell me your doubts. Okay. So I'm restricting everyone's chat to host and co-host. So if you have doubts, you can message me, and also I'm muting all.
Hello.
Sorry. Yes, I am inaudible. Is this fine now? So you guys can message in chat, right? I haven't restricted that thing. Participant can chat with host and co-host. Yeah, you can send me chat if this type of thing happens again. Okay. Okay, so that means I'll explain again. Okay, so let's start with fresh. So, what is a function means? So you can assume that a function is nothing but a machine from a set A to another set B. Okay, so it's like a machine which is working in between two sets A and B. And how it works? So there are two principal things we need to understand is if this is this function, this particular map or correspondence or a machine, if you want to say that this is a function, then there should be two properties it should hold. One is this particular property. What does it says? It says that every element of A should get mapped to somewhere. Okay, so that means every element of A should be we should able to take every element of A as an input. If this is a function, then okay. So this is the first property that this particular map or a machine should satisfy. That every element of A should be taken as an input. Okay, and what is the second property this machine or this rule should satisfy to become a function is that if you have a that every element or every input should have a unique output, right? So this is the second thing it should satisfy is that output associated with each input should be unique. So that means if you are taking A as an input, it should not let two outputs, right? So if you are taking A as an input, there should not exist two different outputs for that B and C. In this case, it's not a function. Okay, so this is informal definition of function. Let's write down the formal definition. So it's similar to this discussion only. So we'll say, so here is the formal definition of function. So we say a map f from a set A to a set B is called a function. Function if every element of A, every A in A, there is a unique B in B, there is a unique B in B, such a way that f is taking A as an input and giving us B as an output. Okay, so this is the formal definition of function. So here understand what are the keywords we need to first focus on. So the first keyword is every. So that means every element of A should get mapped to somewhere. It should not happen that an element of A is not mapped to somewhere. In that case, that particular map won't be a function. Okay, so for becoming a function, we need two criteria. One is every A in A, every element of A should be taken as an input, and another word is this unique word. So that means if you have an input, there should exist only a single unique output associated to that. It should not happen that this A is getting mapped to two different things. In that case, this won't be a function. Okay, so this is the formal definition of function. Now what we will do, we'll first let's understand some couple of simple examples. Okay, so suppose f is a function from a set A to B. Sorry, suppose f is a map now, and then you guys can tell me that this map is a function or not. Okay, so suppose it's a map from a set A to set B, and suppose this set A contains three elements, 1, 2, 3, and the set B contains four elements, A, B, C, D. Okay, and this map is working like 1 is getting mapped to A, 2 is getting mapped to A, and 3 is getting mapped to B. Okay, so now can you tell me, is this a function? You can message, you can enter your yes or no in the chat directly to me. So why do I need to? Okay. Yeah, don't do private. Okay, fine, fine, fine. Okay. So now, okay, so why Ansh it's not a function? It is a function actually. Why it is a function? Because it is satisfying both condition, every and unique. So here what is happening? So there are only three elements in our domain set, 1, 2, 3. Okay, so this set A is known to be domain and this set B is known to be codomain of function. Okay, so there are actually only three elements in the set A, and those three elements are 1, 2, 3. So that means every word is satisfied. That this every property is there in this particular map. Now let's figure out unique is there or not. So unique means for an input we need a single output. It can happen that an output is associated to different inputs. It's okay, but for an input we need a single output. Okay, so here what is happening? One is going to A. Okay, here we have a unique thing. 2 is going to A. Okay, again unique thing, because what is happening? 2 is not going to A and B both. This is not happening. What is happening? 2 is going to single A only. So that means unique is there. Okay, so if unique is not there, then it's a problem. Oh, which account? Yeah. So message on Samiksha 123. This co-host you have to message. Otherwise, I won't get the chat. Okay, fine. So here, what is happening? 2 is also mapping to A. So that means again we have a unique property. 3 is getting mapped to B. So that means 3 is again mapping to a unique output. So that means here also we have a unique thing. So combiningly, we can say that, okay, every and unique, both properties are satisfied. So that's why this map is a function. Okay, is that clear? Why this particular example is a function? Okay, fine. Now let's take one more example. So I'll take example. Suppose f is a map from a set A to a set B. Here I have A, B, C, D, and here I have 1 and 2. Okay, so suppose this map is going like A is going to 1, A is going to 2, B is going to 1, C is going to 1, D is going to 2. Now, is this a function? So, is this a function? Okay. So yes, this is the function. Okay, sorry, what I was saying, I was looking at the chat. This is not a function actually. Because here what is happening? Every word is satisfied. Every is there because A, B, C, D, every element of A is mapping to somewhere. So that means every word is there. But which is missing? Missing is unique. Because here what is happening? A is getting mapped to two different things, 1 and 2. And this should not happen if that particular map is a function. So function says a single input get mapped to single output and every input should get mapped. Okay. So this is the meaning of function. So this is not a function. Okay. Now, the next topic would be how we can, describe a function or write down a function, right? What will be the notations of this particular, how to write down a function, right? So that means what are the notations we can use to write a function? So there are actually several ways to describe a function. Verbally also you can describe by just saying that, okay, if you take this input, you'll get this output. So one of the common ways, one is this arrow way, that you can explicitly write down the inputs for every, write down the outputs for every input, and you can describe that map as a function. Okay, so this is the simple way, explicitly writing down. Okay. Now the another way, which is a more common way, is giving an expression to a function. So what we will do, we are saying that if f is a function from A to B, then we say x is any general element of A and y is any general element of B, and we will relate these two elements by some expression. So we will say that f is a function which is taking x as an input and giving us 2x as an output. So I can say that f of x is equals to 2x or y is equals to 2x. So this is another way to expressing a function. Okay, by giving some particular fixed expression. So I'm saying that if you take x as an input, the output will be 2x. Okay, now you have to judge that this expression defines a function or not. So it's defining a function, very obvious. Okay, so this is the second way. Now the third way is via the graph. So that means you can draw the graph of a function. Now, how can we draw the graph of a function? So as we learned in the last lecture, okay, so we haven't done coordinate geometry yet, but you guys can know from your high school that these are the two coordinates. One is the x coordinate, one is the x-axis, another one is the y-axis. And any point in this plane will have two coordinates, x coordinate and y coordinate. What is its x coordinate? X coordinate is the distance traveled over the x-axis, and what is the y coordinate? Distance traveled over the y-axis, right? So this is your y coordinate, this is your x coordinate. So mean that any point on a plane can can have two coordinates x and y. So similarly, if you want to draw a function, what you will do? You will draw all points with these coordinate x comma f of x. Okay, so whatever input you are taking, whatever output you are doing, you will draw all points in this plane and then map all those points. So in this way, you can figure out what is your graph of a function. Okay, for example, if I want to draw a function f from whole real number to real number, such that f of x is equals to x. Okay, or okay, in place of f of x is equals to x, let's take 2x so that we can figure out x and 2x are different. So what I'll do, if I want to draw this function, what I have to say, we have to track down all points with these coordinate x comma 2x, because this is f of x. Okay, so let's try to track down some of the points. So if the value is 1, the output will be 2, right? So this is the first point, 1 comma 2. If you take 2, you will get 2 into 2, which is 4. So 2 comma 4 will be your another point. If you take 3, you will get 3 comma 6. This will be your another point. So what you need to do, you need to track all those points with the coordinate x comma f of x. And ultimately, at the end, you will get a straight line passing through origin. So assume that this is straight line. Okay. So at the end, we will get a straight line passing through origin. Okay, so this is how that's how you can draw a function. It's actually the set graph of function. Just you have to draw these points x comma f of x. F of x is already given to you, so you can do. Okay, so these are some basic things you can recall. So what is a function? Function is nothing but a map from a set A to set B, which follows two properties. One is every, another one is unique. Okay, so what you will do, you will figure out that every word will be there. So that means every element of a set A can be taken as an input, and another one is every unique should be there. So that means for a unique input, you should get a unique output. Okay, so that's a function. Basically, two things is only there. One is every, another one is unique. That's all. You don't need to understand remember anything else. Two properties a function satisfy, every and unique. Fine. Okay, so now let's jump to week 2. So these one function, onto functions, these kind of functions, these all things you can check, but we will go through all these properties in week 5 also. So we can in detail go through those things there. Okay. Okay, so now let's move to week 2, which is our coordinate geometry. So this week is quite familiar to you guys, I hope. So this in week 2, we generally have so many formulas. So what you need to do, you have to remember the formulas, and also if you are interested, you can go through the proof too. Okay, so first of all, okay, fine. So first of all, we have several formulas. So I'll start with the basic formula, which is the distance between 2 points. Okay, so I am skipping the proof of all formulas because ultimately formulas are important. And if you want to understand the proof, you can just go and uh, uh, watch the video lectures given by the professor. Okay, so they have covered all the proofs of each and every formula, because if I try to cover it, it won't be possible within 2 hours of time. Okay, and also formulas are important, so you have to remember them. Okay. And yeah, so explicitly idea is just making, so the idea of each and every proof is just make some triangle, right angle triangle, and then apply Pythagoras theorem. That's all. Okay, so I'll start with distance between 2 points. So suppose you have 2 points P and Q. Again, whenever we talk about points, we talk about their x coordinate and y coordinate. So suppose P is a point with coordinate x1, y1, and Q is a point with coordinate x2, y2. Then what is the formula which can give you the length of the line segment PQ? So what is the distance between P and Q? So the distance between P and Q is given by the formula x minus x1 the whole x minus x2 the whole square plus y1 minus y2 the whole square. Okay, so this is the very basic general formula you guys may have learned in your high school too. So this is the formula for computing the distance between any 2 points. So the thing is, that's why I haven't taken the main chat, because whenever a message comes up, my attention goes there. So I'll just check this. Okay. So this is the distance formula, that if you have 2 points P and Q, P with coordinate x1, y1, Q with coordinate x2, y2, then you can find out the distance between these 2 points via this formula under the root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Okay. Now, let's move to the next formula, which is area of a triangle. Okay. So suppose you have a triangle with three coordinates ABC, 3 points ABC, three vertices ABC. A with coordinate x1, y1, B with coordinate x2, y2, and C with coordinate x3, y3. Okay. So then we can actually compute the area of this particular triangle using a formula just depending on the coordinates of these 3 points. Okay, so what is that formula? So it says that the area of triangle ABC is actually 1 by 2 of modulus of. So here you have to remember the pattern. First of all, x1, x2, x3, and then with 1 we have y2 minus y3. With 2 we have y3 minus y1, and with 3 we have y1 minus y2. Okay, so this is the formula for area of triangle. We can compute area of triangle just by looking at the vertices. Okay, ABC. Again, I am repeating that in week 2, important thing is remembering the formula. If you know the formula, you can easily answer the questions too. Okay, so these are the first two formulas. Now another one is the section formula. Section formula means if you know that a point R is dividing this whole line segment P and Q in ratio M and N, then how can you figure out the what is the coordinate of point R based on the coordinates of point P and Q? X to y. Okay, so it says that the coordinate x is nothing but mx2 plus nx1 upon upon m plus n, and the coordinate y is nothing but my2 plus ny1 upon m plus n. So this is known to be a section formula. So if you have 2 points x1, y1 and x2, y2 respectively, and if we have a point R dividing this line segment into m ratio n, then the coordinate of x and y is given by this particular formula, mx2 minus nx1 by m plus n, and my2 minus ny1 upon m plus n. Okay. So this is known to be a section formula, which I think you're already familiar with in your high school too. Okay. Fine. Now let's go to the topic of line. So, okay, pause. Hey, which I think. Sorry for that. It's okay. Okay. So now let's go to the concept of straight lines. Again, I am opening the chat because it's already popping up. So, okay, so now straight lines. So what we need to do, we need to figure out that if we have a straight line, then what will be the equation of that straight line? Or in general, if you have a line, then how can you figure out what is the equation of a straight line? Okay. So suppose first of all, I'll cover two lines. One is the vertical line and another one is the horizontal line. So what is a vertical line? So vertical line means that line which is parallel to y-axis. Okay. So if you have a line which is parallel to y-axis, this is known to be a vertical line. Now here I can ask you some series of questions. So suppose that this value is x is equals to 2. And if you have any point P on this line, so can you guys tell me what will be the x coordinate of this point P? What will be the x coordinate of this point P? 2, right? Obviously, because it is covering 2 distance over the x-axis. Now suppose I'll take one more point on this line. Suppose here I'll take a point Q. Now what will be the x coordinate of point Q? Again 2, right? So here what is happening? So whatever point we have on this line, all are having x coordinate is equals to 2. And this is also true vice versa. So that means if you have any point with x coordinate 2, that point automatically lie over this particular line, because ultimately it should travel 2 unit distance in x-axis. So we can say that the equation of this green line is nothing but x is equals to 2. Okay. So what is an equation of line means? It should be able to represent the relation between the x coordinate and y coordinate of all points lying over that line. Okay, so that means if you have equation of line, you can easily figure out what are the points lying over that line or not. Okay, so that's the whole purpose of creating an expression for line. So similarly, you can say that the equation of this line or equation of this particular horizontal line is nothing but x is equals to 2. Okay, but there is no special thing about 2. You can generally say that if you have a line, a horizontal line, which intersecting at x-axis at x is equals to c, then the equation of this line is nothing but x is equals to c itself. Okay, so that's how we can get a expression for any vertical line, x is equals to c. Now the second type of lines are horizontal lines. Okay, so horizontal lines are those lines which are parallel to x-axis. Okay, so suppose this is the line which is parallel to x-axis. Now assume that this line is intersecting y-axis at y is equals to 4. Okay, so now if I take a point P here, so can you guys tell me what will be the y coordinate of this point P? 4, right? Similarly, you can take any point Q over here. What will be the y coordinate of this point Q? Again 4. So that means if you have any point which has y coordinate 4, that will lie over this line, and any point which is lying over this line will have y coordinate. So that means this particular expression y is equals to 4 actually tell us all things about this particular horizontal line. And again, there is nothing special in this particular 4. You can replace this with any t. So that means the equation of the horizontal line which is intersecting y-axis at y is equals to d is actually y is equals to d itself. Okay, so I'll recall for a vertical line equation of line is x is equals to c, where what is c? C is the intersection point of line and x-axis. Okay, so for a horizontal line, the equation of line is y is equals to d, and where what is this d? D is the intersection point of line and y-axis. Okay, so that's all about the vertical line and horizontal. Now suppose we have any general line which is neither vertical nor horizontal, then how can we figure out the equation of line? Okay, so assume that this is the line L. So what we will do, for this line L, we actually have several forms. So someone says slope intercept form, intercept form, or 2-point formula. So what you can do, you can remember two formulas, and by those two formulas, you can create any form, whatever required. But I'll say just remember two formulas. They they are more than enough to solve any type of question based on straight lines. Okay. So what are these formulas? So one is known to be the slope intercept form. Okay. Okay, so what is a slope intercept form? So it says that you can give the equation of straight line by y is equals to mx plus c, where what is m? M is the slope of a line, and the slope is nothing but the change in y upon change in x. So that means if you have 2 points over here, p and q, with coordinates again, I'll take x2, y2 for q, x1, y1 for p. Then the slope is defined as the ratio of the change in y2, the change in y coordinate upon change in x coordinate. Okay, so actually what happens, this ratio stays still over a whole line. So no matter what points you will take, this ratio will be unique. And this ratio is known to be the slope of a line L. Okay, so slope is defined by this quantity, and also it is also defined by tan of theta, where theta is an angle created by the line and the x-axis. Okay, I'm sorry, it's an anti-clockwise direction. Okay, so this is the angle theta. So that means there are two formulas. One is tan theta, and another one is y2 minus y1 upon x2 minus. Yeah, you can do this by tan theta too. Tan theta is same as y2 minus y1 upon x2 minus. Because if you create a right angle triangle over here, you can easily figure out that this ratio is nothing but tan theta only. Okay. So this is known to be a slope intercept form of any straight line. Now another formula is 2-point formula. So this is known to be a 2-point formula. So that means if you have 2 points, then you can find out the uh, equation of line by using the coordinates of these 2 points. And what is that equation? It says that y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x. This is known to be the 2-point formula. So that means if you have 2 points p and q with coordinate x1, y1, x2, y2, then you can figure out the equation of line is nothing but y minus y1, which is equal to y2 minus y1 on x2 minus x1, x minus x1. Okay, so this is the general equation of general thing for line.
Hey, hello everyone. So, are you able to hear me? Can somebody just reply? Are you guys okay? So you are able to hear me. Okay. So yeah, so there's some electricity issue from Samikcha's side. So she'll be joining in some time. Till that time, I'll be taking the session. So okay, so today was the doubt session, right? So yeah, you can just let me know what your doubt is. I'll just go through that. So I hope week one the summary session has already been done in the previous one of the sessions, right? Okay, so this was uh, okay. So whatever the doubts that you have, you just write it in the chat box. I'll just try to go through it. Yeah. So have you all gone through the content? First of all, the week two content. Not started. Okay. No. Okay. Okay. No issues. So we have not started week two itself. Yeah. Give me a minute. I'll just connect it via my writing device. Just give me a minute. Yeah, guys, just give me a minute. I'll just connect it via my. I'm just connecting a writing device. Okay, you just have to wait for some time because it was a sudden like some electricity. It's raining at her home, so that's why it just take me 2 or 3 minutes. I'm just connecting. So yeah, you just have to wait for some time. Are you guys able to hear me now? Can you just reply me in the chat box? And thank you for, and sorry for this, making you wait for some time. Okay, okay, no problem. So I hope week 2, the summary has been done, right? So I hope the SSE part has not been done. This is what has been said to me, right? Sum of a squared error is not done, right? Correct? Yeah. Okay, so we'll start with sum of square error, and then we'll move to the doubts, whatever you have, and then we'll solve whatever the doubts that you are facing. Okay, so let's start with sum of square error. Okay, I hope all the formulas has been discussed from the starting. I am not going to repeat that. And right, so let's start from the sum of square error itself. I hope the straight line, everything has been done. The distance between two parallel lines, distance of a point from a line, perpendicular distance, everything, all the different forms of line, general form, slope intercept form, x intercept, y intercept form, two intercept form, everything has been done, I hope. So let's start from the last. I guess this is the last portion of your week 2 that you call it as a sum of square error. And many a times, if any of you are from ML background, you would be knowing of sum of square error. Or many a times you call it as SSC also. Okay. Are you guys able to hear me? Yeah. Okay. No problem. So I hope everybody is able to hear me. Okay. What is? Oh, the formulas are still left. Huh? Is it? Okay. From where I have to deal with? Which formulas are left? Can somebody tell me? Because the voice is very low. Okay. I'll just connect it to. Is the voice fine now? Okay, so voice is fine. Okay, no problem. So I'll just start from the starting then. Okay. So the first thing that we go through, I go this, all the 4 quadrant, at least this you would have been dealt with, right? Any point, this is positive, correct? So this is your x coordinate, this is y axis and y axis, and then you have a 4 quadrant, right? 1, 2, 3, 4. Let's, for example, if you are dealing a 3D geometry, right? Then what do you think? What will be the number of a quadrant? So now, as of now, whatever I have drawn, that is a 2-dimensional, right? You're just using left to right and then top to bottom, right? 2-dimensional figure. If, let's, for example, I would have been dealing with a 3D geometry, right? What do you think? What would be the number of a quadrant, right? So here we have 4. Can somebody tell me? Okay, 8 quadrant. Nice. Correct. So I hope now you're already aware of that also. Here, let's, for example, there will be a point, there will be negative, positive. Here it will be negative, negative. And here it will be positive, negative. So this was pretty simple. Okay, then the second topic that you must be knowing from this week is the distance between your 2 points, right? So any 2 point has been given to you, right? Let's, for example, this x1, y1, and then x2, y2. Then you can directly calculate the distance. It's pretty simple. There's nothing much to be discussed, but even though if you want to go through the proof, you can go through the lectures, right? You can just draw the perpendicular, and there's a pretty simple way to calculate how does the formula get derived also. You can just drop a perpendicular here and then a perpendicular here, and then you can calculate the distance between those two also from the Pythagoras theorem. Okay, so this distance, you can get it if you just drop a perpendicular point here from xy, y1 to on the x-axis. And similarly, if you drop a perpendicular from x to y2 to this, again to the x-axis itself, right? And one perpendicular from this point to this line itself, you'll be having a right angle triangle, and then you can directly calculate from the Pythagoras theorem the length of this hypotenuse, okay? And then when you'll be calculating the distance, it will come out to be something like x2 minus x1 ka whole square plus y2 minus y1 ka whole square. This was also pretty simple, and this is what the distance between a 2 point is, okay? So the distance between x1 y1, that is a, let's say example, and b, that is x2 y2. Okay, so this also was already dealt with. So now after that, you must be knowing about the section formula, right? So the section formula has been done, or should I write? So I hope you already know the formula, right? Yeah, section formula is already been done. Correct. Right. So simple. This is pretty simple. If you have a straight line, okay, x1 comma y1, and you have x2 comma y2, and if the ratio has been given, right, m is to n, then you can directly calculate the coordinate x and y. Correct, right? This point is internally dividing this straight line in the ratio of m is to n. Correct. So the formula would be pretty simple. You can directly remember it as x equals to what? M times x2 plus n times x1 upon m plus n. Let's for example, if it was externally cutting the line, so this was a very simple thing. And similarly, you can calculate mx y2 plus ny1 upon m plus n. Now, I'm asking you, so this was internally cutting the line segment into mx to n. Now, if it is externally cutting, cuts the line segment, so this is a straight line. Okay, and then there's a point P, and this is m to n. What do you think? What should be the value of this P coordinate x comma y? What will be the value of x and what will be the value of y? Anybody? Correct. So Nikunj has given the correct answer. Even the Nikunj has given the correct answer. Yeah. So only in spite of wherever we were writing plus, like m plus n, right? Is a step to write minus n. Correct. Correct. Yeah. So whoever was written is correct. You can just replace m n with minus n. You'll get the same answer. So mx2 minus nx1 upon m minus n. Similarly, here also m y2 minus n y1 upon m minus n. Correct? Yeah. Let's try to solve this question. So you have been given a line segment where the point 2, 5 has been given and q 8, 8 has been given to you. And it is internally dividing in the ratio of 1:2. There is a point A. What will be the coordinate, x coordinate of A, and what will be the y coordinate of A? Can somebody tell me? So there's a point P. The coordinates are 2, 5 and a point Q with a coordinate of 8, 8, right? So there's a point A that divides PQ, a line segment PQ, in the ratio, and that is internally 1:2. Then what will be the value of x coordinate of A and y coordinate of A itself? Okay. Okay, so Amit Sharma is asking, please explain it again. the which one? The externally cutting. So this Amit, this was pretty simple. So we dealt in the starting. We dealt with a line segment. So there was a line segment. Let's for example AB. So this was a line segment. Okay, with the coordinate, some coordinate was given x1, y1 and x2, y2. So if a point internally dividing this AB line segment, okay, let's for example P is a point with a coordinate x comma y, and the ratio has been given to you, m is to n. Okay, if a point is lying inside the line segment, right, somewhere from A to B itself, that means P is cutting this line segment internally, right? In a similar fashion, let's for example, a straight line has been given to you, okay, A comma B, and then has been said that a point that is also, if you'll extend this line segment, right, a point will come P, okay, and then the ratio has been given. So here, this P doesn't lie inside this line segment, whatever was given earlier, okay. So if we'll extend this line segment, then the P will come, okay, and then the ratio has been given as something as m is to n, right? So this P point has been externally cutting this line. Okay, so if we'll extend this line segment, then the P will come, and the ratio has been given as AP is M and BP is N. Okay, then the formula, the second formula, you can just replace N with minus N. Is it fine, Amit? I hope you got the idea. Okay, got it. Okay, so the answer has been given by Simi Sama 4,6. Yeah, I hope everybody is correct. 4,6 is correct. Yeah, let's move to the next topic then. So you are able to understand this. Now let's move to the next topic. So, and let's for example, if you have to calculate directly the midpoint, right? If you have to calculate the midpoint directly, how will you calculate? This is pretty simple. You can just, okay, let's for example, you have been given a point. Four comma minus 2 and 0 comma 2. What will be the midpoint of this 2 point? Yeah, 2 comma 0, correct. So here, even though you can use a formula, but it's better you can directly add this to coordinate x comma, because it's been given as a midpoint, right? So the ratio m is to n will be 1 is to 1, right? So you can directly do it as x1 plus x2, what has been given by 2. Similarly, y1 plus y2 by 2. So you'll get here as x coordinate, and here you'll be getting as y coordinate. Now let's move to the area of a triangle. Here also, I hope the formula has been discussed. So, and whenever, so I'll just give you one idea about area of a triangle. Whenever you are calculating area of a triangle, the first thing that you should be checking, whenever has been given in the exam also, if you have been asked to calculate the area of a triangle, first check whether the line is collinear or not. Okay, if the line is collinear, what will be the area of a triangle? If 3 points has been given to you, and those 3 points are collinear, what will be the area then? And why? So the area will be 0. So many of you are saying, why the area will be 0? Because all the 3 points, if they are collinear, that will lie on a straight line. If it's lying on a straight line, it's not forming a triangle. Correct? That means the area will be 0. I hope you're able to understand this. Yeah. So can you just calculate the area of this 3 points? So the points given are what will be the area of a triangle? So whatever I said, right, you don't have to directly use the formula. Check it whether the points given are collinear or not. And how do you check the points are collinear or not? You just take 2 points, right? You just take this 2 point first, PQ and then take any PR or QR. So check the slope. If the slope are same, right? That means what? These 2 points are parallel to each other. And how can this 3 point? So this two, let's for example, PQ. If you have calculated the slope, right, of PQ, and then calculate the slope of QR. If both are same, that means what? The point must be parallel to each other, or maybe lying on a same straight line. Then only the slope can be same, right? That means what? It can't form a triangle. That means the area will always be a 0. Okay, so how to calculate the slope? So, okay. The next topic that we'll be dealing with is how to calculate the slope of a straight line. Okay, first check if you have been given 2 points, then how do you calculate the slope of a straight line? So, we'll start with slope of slope of a straight line, or if you have been given 2 points, how do you calculate the slope? Okay, slope is nothing but it is denoted as the change in y as compared to change in x. This is how you calculate the slope of a line, or maybe a. So normally you calculate the slope of a straight line only. If you have been given 2 points, that means any 2 points will pakka form a straight line, right? And then you calculate a slope of that straight line. Basically, slope is what? Normally you'll come to know that when you generally calculate the angle for any straight line, you generally calculate the angle that it makes with the positive x-axis. Okay, and that tan of that angle is generally your slope is. Okay, and how do you calculate? Normally you can calculate with the given data points at the point also. And how do you calculate that? In change of y as compared to change of change of x. Okay, let's for example, a point has been given to you x1 y1, and here it is given as x2 y2. Okay, if you have to calculate the slope of this line, because this 2 point will pakka form a straight line for sure. If you have been given a 2 point, right, that means what will form a straight line, and then you can calculate the slope of the straight line. Even though you can calculate the equation of the straight line also. So first we'll see that how to calculate the slope of that 2 point has been given to you. So 2 point will form a straight line, and then how do you calculate the slope of that straight line? Okay, and what is the formula that I gave you? It's the change in y as compared to change in x. Okay, normally in the calculus and all, you generally calculate it as dy by dx, right? The change in y as compared to change in x. Okay, to check how does curve moves and all. Okay, so that will come to know in the later part of her, maybe from the week 6 and 7. But as of now, you just think of as slope is some slope. How do you calculate a slope? Is the change of y as compared to change in x. Okay, it can help you. So generally we calculate the slope. It can help you to tell both the direction and the stiffness of a line. Okay, and the formula generally is del y by del x. Okay, now, and this you call it as a tan theta also. I told you, right? So for any straight line, it's for example has been given on the, this is a positive x-axis, right? And this is y-axis. So any line has been given to you, right? For this straight line that has been given to you, line 1, okay, the angle that it makes, right, with the positive x-axis. So every point is important. The angle, this line, it makes with the positive x-axis. So this is positive x-axis, right? And this is the theta that it makes. So tan of that theta is generally your slope is. Okay, or you can calculate it. If you know the angle, then you can directly calculate the slope. There's no problem in that. Or you should be knowing at least 2 points to get the slope of this line. Okay, so you can calculate the slope also. How do you calculate? Del y upon del x. Okay, so this is what y2 minus y1 upon x2 minus x1. This gives you an idea about the straight line. How does the straight line go? Whether the slope is positive, whether the slope is negative, whether what angle it makes to the positive x-axis. Okay, this is what your slope tells you. If you have the knowledge about the slope of a straight line, you have almost you're knowing everything about, mostly you're knowing everything about that straight line. I hope this is making sense. Okay. So let's for example, this is what x1, y1 is x2, y2. So you can calculate it. Let's for example, you drop a perpendicular, you will drop a perpendicular here also, right? So what do you think? What will be the length here? So this will be x2 minus x1. And this will be what? y2 minus y1. Correct? And what is tan theta? What do you mean by tan theta? In the form of perpendicular, hypotenuse, and base. What is tan theta? Can somebody tell me? What do you think? Tan theta you would have read, right? In class 9, 10th, 11, 12th. Yeah, correct. Perpendicular upon base, right? And what is the perpendicular here? y2 minus y1. What is the base? x2 minus x1. Correct? And this is what we were saying, right? This is the slope. That is what we have said. The slope of a line is what? Del y upon del x. And this slope is what? The angle that is the angle that it makes with the positive x-axis, right? The tan of that angle generally tells you the slope of that line. Okay, and that is how we get the slope of a line. Correct. Okay. So now I hope you must be knowing about the slope at least. Now, the second thing that we read is the second thing that we'll be reading is now you know the slope of if you have been given the slope of a line, right? So the minimum thing that is required to know the equation of a line. So let's say example, this is L1. You know the slope. So the slope has been given to you. Let's say example, the slope has been given to you is M. But if you will check it clearly, right, there can be n number of straight line, right, with the same angle that it makes with the x-axis, right? You can see that, right? All this line are making almost the same angle, right? Here also it's making the slope is M. Here also its slope is M. Because you already know that, right? If you're having a parallel line, right? If you have a parallel lines, correct? You can see that this L1, this was L2, L3, L4, L5, L6, right? This all angles will be making the same angle tan theta with the positive x-axis, right? But we don't know which line we are talking about. If I have to get the equation of L1, right? How can I get? Only slope can't give me the straight equation of a straight line, L1, because you can see that L2, L3, L4, L5, L6 all have the same angle with the positive x-axis. So we can know about the slope of a line. So one more thing we'll be needing, right, to check, to calculate the equation of the straight line. What do you think? What will you be needing? One more thing, apart from this slope. Correct. The intercept or a point or a single point where it passes through, right? If you have, let's for example, this line, right, L1. If I know that this line has a slope of M and passes through this point, now this will be a unique line L1, right? Correct? And let's for example, I know that the slope of a line is M and it passes through this point, B. Okay, then we can say that I have the equation of that unique line L2. Correct? I hope this is clear to everybody. So only slope is not required to know the perfect equation of the line. If you have been given only the slope, you can have an infinite number of a straight line with that same slope M. But you need at least one data point or a one point through which it is passing through. That straight line is passing through. So that means what? Two things is required. Minimum two things. One is a slope, and the other thing is a point through which this straight line is passing through. Okay, if you have these two things, then you can directly get the equation of a straight line. Okay, I hope this is making sense. Okay, so now I'm asking you, what will be if you have been given a question? So if you have been given a question that a line, or first of all, you give me a slope. So question has been given. Tell me the slope M if point has been given, one point is 0, 0, P1, and P2 point is minus 3, 5. What will be the value of the slope M here? It's pretty simple, right? Minus 5 by 3. So how do you calculate? Y2 minus Y1? and x2 minus x1. Correct? And now if I want to know the equation of this line, right? So that equation of the line also, we can get it from this 2 point, because I told you in the starting, if you have been given a 2 point, that for sure you can get the equation of a line, because you can calculate the slope from this 2 point. And this, if you have a slope, right? And then you already know that this line is passing through origin or from minus 3, 5. So any of the 2 points, you can use it to calculate the equation of a straight line. Are you able to understand this, everybody? I hope this is pretty simple, not that difficult to understand. Yeah, correct. So I already told you, if you have, and some of the important properties of a straight line, I already told you, if two parallel lines are being given, then they'll be having a same slope or same value of tan theta or same value of m that we were talking about. So if two parallel lines has been given to you, that means what? The slope m1 will be equals to m2. Okay, correct? And what is the properties of a two perpendicular line? What is the equation that you get? So whenever you are dealing with a two perpendicular line, right? Then you get an equation something like m1, m2 is equals to -1. We'll prove that. We'll see that how does it comes. Okay, as of now, you can just think of as two parallel lines will be having the same slope, and two perpendicular lines, the product of those two slopes will be equals to -1. Okay, so now deal with this. How do you get the equation of a straight line? There are some 4-5 form. Okay, so equation of a straight line. Okay. So now the first form that we'll be reading is the slope intercept form. Okay. So slope intercept form, if you have a slope and an intercept, you can get the equation of a line. And how do you get the equation is mx plus c. Can somebody tell me this c is a x-intercept or a y-intercept? And how do you calculate if you have been given an equation? How do you check whether, like, how can you calculate the x-intercept and a y-intercept? Okay, for this question, this is a y-intercept. Can somebody tell me for this same equation, this L1, what is the x-intercept? No, I'm talking about the x-intercept, not y-intercept. So whenever you have to calculate y-intercept, what do? You put x equals to 0, you will get y-intercept. So what is the value? If you will put x equals to 0, you will get y equals to c. That is y-intercept, correct? When you have to get the x-intercept, you put y equals to 0, right? Then you will be getting x equals to minus c upon m. Are you getting me, everyone? So if you have to calculate, so in the given question, right, if you have to check whether it's x-intercept or y, put x equals to 0, whatever is left. So y equals to c, right? That means what? Whenever x is 0, y is equals to c. So whenever you will plot this straight line, right? Correct? So this straight line has a slope of m, okay? And this passes through which point? 0, c. Correct? So 0, c, it is somewhere here, right? So x should be 0, but y is c. C depends on whether, as of now, I'm just treating c as some positive value. So 0, c, right? And the slope will be something like that, right? So this is your straight line, y equals to mx plus c. Is it clear to everyone? Okay. Okay. So now the next form is the first form we have dealt with. Now the next form is, if you have been given a point, two different point has been given. So from there also you can directly calculate the equation of a straight line. Okay. So how do you calculate? Let's for example, okay, so first you will deal with the point, like if you have been given the slope only. So the first thing that we have dealt is if you have been given the slope and the y-intercept, you can directly write it as it is. Y equals to mx plus c, where y is the slope and c is the y-intercept. Okay. For the x-intercept, we'll see that what is the equation. Now the second form is the point slope form. Straight line. Okay. Here you have been given the m as a slope and a point has been given to you. X1 comma y1. Okay, so here let's for example, so a point has been given here x comma y1. You just randomly take a point x comma y. Correct? And the slope is what has been given to you m already. Now if you have to get the equation of a straight line, right, that will be in the form of xy only, right? Because your straight line will be in the form of some xy. So this, you just think that this xy is lying on the straight line that has been given to you with the slope m, and a point that is passing through is x1 y1. Correct? So let's for example the slope m, you can directly equate it to what? Y minus y1 upon x minus x1. Correct? So the equation will become y minus y1 equals to m times x minus x1. This is your equation of a line. Y equals to y1 plus m x minus x1. So this equation you will use it. You can use it when you have been given a slope and a single point. Okay. So this is what you can use it. So this is also pretty simple. In the end, you will see that whatever the equation that has been given, right, you can just interchangeably, you can change it from one form to the other form. That's not really important. As I have to just cover everything, I'm just covering it. In the later form, you'll see that you can, from a straight line, you can go to the any form, and from any form, you can go to, like, you can just understand everything about the y-intercept, x-intercept, or you want to know like the slope of a line, you can directly calculate just by seeing the straight line itself, the equation of a straight line. Okay. So the next point is the 2-point form. Now, 2-point form is nothing. You have been given 2 points now. Here also you can do the same thing. You have been given, right, x1 comma y1, and you have been given x2 comma y2. You take it 1 point x y, correct, and then calculate the slope using x1 y1 and xy, and then calculate the slope using xy and x2 y2. Equate both, and then you will get the equation of a line in the form of a xy, right? So xy is variable, so that is lying on a straight line, and 2 point has been given to you, x1 y1 and x2 y2. Okay, so you can directly calculate that also. So you can directly calculate it. Just take a slope of this line itself. That will be what? y2 minus y1 upon x2 minus x1, right? And that will be equals to what? Y minus y1 upon x minus x1. This is the equation of a straight line. If you have been given 2 data point or 2 point has been given to you, then you can directly calculate the equation of this line. Is it clear to everyone? Anybody has any doubts? I don't think so. Okay. No. Okay. So I hope the different types of form we have covered. Now the angle between 2 lines. Okay. Let's for example, you have been given 2 lines, L1 and L2 has been given to you. And then you have to calculate the angle, theta. Or phi, whatever it is. Okay, so L1 and L2, 2 lines has been given to you. This is x coordinate, y coordinate. Now, if you have to calculate the value of this theta, right? If you have to calculate the value of the obtuse or the acute angle, whatever. Let's for example, we are just calculating the value of the acute angle. Acute angle, I hope you are already aware of that. That has the value, like the angle is less than 90. Okay, so that you call it as acute angle. So this you have to calculate the angle between two straight lines, right? So there's a nice formula. Directly you can calculate this tan theta tan of this phi as m2 minus m1 upon 1 plus m1 m2. Okay, you can just take it as a mod. So let's say example, the slope of this line is m2, the slope of this line is m1. Okay, and if you have to calculate the slope, the acute angle, you can directly calculate tan theta as m2 minus m1 and 1 plus m1 m2. Okay, in this way, and you already know that, you can directly see that. I told you in the starting, if two lines are perpendicular to each other, the m1 m2 is equals to what? Minus 1. Let's for example, if you are calculating the angle between two straight lines, those are perpendicular to each other, right? If two lines are perpendicular to each other, right? So what will happen here? The tan theta, you already know that. What is the value of tan 90? Can somebody tell me what is the value of tan 90? 1 upon what? Not defined. Okay. Normally, what did you call? 1 upon 0, right? So you'll just equate this value 1 plus m1 m2 to 0. You'll get it as m1 m2 equals to minus 1. That is what I said in the starting. If you have two straight lines, those are perpendicular to each other, what will happen? The product of those two, the product of the slope of those two lines will be equals to minus 1. And that is what we are getting from here also. So the equation of a line tan phi is equals to what? M2 minus M1 upon 1 plus M2 M1, right? And if this was 90 degree, that means what? 1 upon 0, right? And then when you will equate it to 0, you'll get M1, M2 as minus 1. Okay? Is it clear to everyone? Okay. So I'll just write it everything here. See, normally what happens, so you have 2, 3, 3, 4 forms I have taught you now. So the first thing that we learned is the slope point form. What is that? Y minus any point, let's say example, y1 equals to m times x minus x1. Okay, so a slope has been given and slope has been given to you and a point has been given x1, y1. So you can calculate the equation of a line like this. Now the next that we have learned is, if we have been given the slope intercept form, right? Slope intercept means y-intercept has been given to you and the slope also has been given to you. Then this is very simple, y equals to mx plus c. The third thing that we have studied today is, if 2 point has been given to you. So this is much easier. Y minus y1 upon x minus x1 is equals to what? y2 minus y1 and x2 minus x1. Just have to equate the slope of those two lines and you will get it. Okay. There is one more thing. Let's for example, you have been given x-intercept. Okay, so first deal with, if you have been given slope and the y-intercept, x-intercept. Okay, if you have been given a point, if you have been given a slope and x-intercept, then the equation is something like y equals to mx minus d. Here if you have to check, can somebody tell me what will be the x-intercept here and what will be the y-intercept? If you have to get the x-intercept, I told you something, right? What will you do to calculate the x-intercept? And what will you do if you have to get the y-intercept? Yeah, if you have to get x-intercept, you will put y equals to 0 and you will get it as x equals to d. And if you have to get the y-intercept, you will have to put x equals to 0. Correct? You will get it as minus md. Okay, so this was the fourth form. And one more form is, if you have been just given the x-intercept and the y-intercept. So x-intercept has been given to you and y-intercept has been given to you. Okay, then you can directly calculate it as x upon a plus y upon b equals to 1. Here also, can somebody tell me what will be the x-intercept and what will be the y-intercept? If you have to get the x-intercept, put y equals to 0, you'll get x equals to a. And if you have to get the y-intercept, put x equals to 0, you'll get y equals to b. Correct? So if both the intercept form, the x-intercept and the y-intercept has been given to you, you can directly get the equation of a straight line like this. Okay. Now, I'm just telling you there's a general form also. So normally you'll be given like this, ax plus by plus c equals to 0. Now, from here, you have to convert this general form. So this is general form. Now you have to tell me what is the slope of this equation. Slope you have to tell me. You have to tell me y x-intercept. You have to tell me y-intercept. So these three things you have to tell me. And one more thing, if a line is perpendicular to each, like a line that is perpendicular to this straight line, what will be the slope of that straight line? A perpendicular line, what will be the slope of that? M2. Let's, for example, this is M2. This is M1. That is, you have to calculate. First thing, what is you have to calculate is the slope of this line. The second thing is you have to calculate the x-intercept. The third thing is you have to calculate is y-intercept. And the fourth thing that you have to calculate is the equation of a line that is perpendicular to this straight line. Tell me, have you calculated the first thing, the slope? Okay. Yeah. So to calculate the slope, right? This is very simple method, right? So let's, for example, ax plus by plus c equals to 0. You already know that if I'll convert this general form in y equals to mx plus c form, then we will be having slope and we will be having the y-intercept for sure, right? So what we have to do is we have to make y, the term y in the left side. So let's make it by equals to what? Minus ax plus, sorry, minus ax minus c. But what we have seen is y here, the coefficient of y should be 1, right? So what I can do is I'll just divide everything by b. So here also I'll divide with b. So I'll be left with what? Y equals to minus a upon b times x minus c upon b. Now you can see that this is the slope. So m is equals to minus a by b. What is the y-intercept? Minus c by b. If you have to get the x-intercept, put x equals to, if you have to get x-intercept, put y equals to 0, you'll get the value of the x also. Okay, so that you can calculate it. And now the next part, what did I say is, you need a slope, the equation of the slope of an equation that is perpendicular to this line, right? So what did I say? If you have a two line, those are perpendicular to each other, the product of the slope of those two lines will be equals to minus 1. So here it is minus a by b times of m2 equals to minus 1. Correct? So m2 will be equals to b upon a. So this will be the equation of the slope of line that is perpendicular to this given line. Is it clear to everybody? Correct. So, yeah, Nikul, you're correct. M2 will be B upon A. And I hope you already know that if two lines are parallel to each other, so let's, for example, you have been given A1x plus B1y plus C1 equals to 0. This is L1. And you have been given A2x plus B2y plus C2 equals to 0. This is L2. Now, the first thing that you have to tell me, if both L1 is parallel to L2, you have to tell me a condition in the form of A1, B1 and A2, B2. And if the line is parallel to each other, it's perpendicular to each other, then what will be the condition in A1, A2, B1, B2? I'm just giving you 2 minutes. You just calculate it and tell me what will be the condition that we'll be getting. If the line, first tell me, if L1 and L2 are parallel, what you have to do is calculate the slope of this line, calculate the slope of this line, and then equate it, because you already know that if two lines are parallel to each other, the slope will always be parallel, like equal. Yeah, so for parallel, Nikunj has written correct. Okay. So many of you have written, I guess Navneet also. Yeah, Simi Sharma, I'll just upload this written notes. We'll be uploading, keep on updating on the portal itself. So there will be a folder, supplementary content. So there we will be uploading all the slides that we'll be using. Okay. Okay. So you just have to, so we have calculated the slope, right? So what was the slope? The slope was minus A upon B, correct? So here also we'll be getting minus A1 upon B1 will be equating to minus A2 upon B2, correct? I hope this you are able to follow. So the condition that we'll be getting is A1 times B2 equals to A2 times B1. This is the first condition. Now, the second, if both are perpendicular to each other, that means what? Minus A1 times B1 times minus A2 times B2 should be equals to minus 1. Correct? This is what you will be getting. So here you will be getting what? A1, A2 equals to minus B1, B2. This will be the condition that we'll be getting if both the lines are perpendicular to each other. Okay? I hope this is fine. Now, the next thing that you must be knowing is the distance. If you have been given a point, right? And a line has been given. So this distance you should be able to calculate it. Okay, so this distance you should be able to calculate. Let's, for example, this point has been given as x1 comma y1, and this straight line is ax plus by plus c equals to 0. Okay, so this you can calculate this distance. If you have to calculate this distance, you just drop this point on this line itself. So if you drop this point, a x1 plus b y1 plus c, okay, and then a square plus b square. This will be the equation of a line. This will be the distance of this point from a random straight line. Okay, normally you call it as a perpendicular distance also of a point from a given straight line. Okay, now this is the first thing. The second thing is, if you have been given two parallel lines itself, then how will you calculate the distance? Then you just take a point on one of the line and then calculate the distance between that point from that line itself. Okay, whenever you'll do that, you'll get this distance d as, let's for example, this was x plus by plus c1 equals to 0. Here also ax plus by plus c2 equals to 0, because both the lines are parallel to each other. If the lines are parallel to each other, the slope will be equal. So ax plus by will be same, right? Only the intercept will change, because you already know that if two lines are parallel to each other, the slopes will be same. Okay, so the distance d that we will be calculating is C2 minus C1 upon A square plus B square. This you can just take it as mod, because the distance that we'll be calculating will always be some mod, like positive value itself. The distance can't be negative. We're not talking about the displacement, we're just talking about the distance. I hope this is clear to everyone. So whatever the concept that was there in the week 2, we have dealt. Only the sum of a square error, the today's last topic is been left. Okay. So the last topic that we'll be doing is the sum of squared error. Okay. You call it as SSC also. So from the name itself, it is pretty clear that we'll just calculate some sort of an error, then we'll square that, and then we'll sum it. Okay. So the name itself tells you you're just calculating some sort of a error. Then you do the square of that error, and then you do the summation of that squared error. Okay. Is it clear to everyone? What do you mean by sum of square error? You are calculating some sort of an error, then square it, and then do the summation. Now, what is the intuition behind that? Why are we calculating sum of the square error? Okay. See, the sum of the square error is nothing but the deviation of a predicted linear model from an actual data set. Let's, for example, this you will be learning in much detail whenever you will be learning some of the ML courses. Okay. So as of now here, it's just the basic idea you just have to get. Whenever you are creating some sort of a model, okay, linear model, okay. So now in the childhood also, maybe in the class 10th or 12th, whenever you were dealing with, you're going to the physics lab and all, right? You're doing some sort of a Ohm's law you were using, right? This voltage equals to current times the resistance that you get it, right? So there also in the experiment what you were doing. So whatever normally you will do some experiment, you will get some sort of actual data. You'll pass some voltage, current, and then you'll calculate the resistor, right? Resistance you'll be calculating, but there will be some actual value of the resistance also, correct? So but you'll always be seeing that the actual value of the resistance and the value that you will be calculating during the experiment, while doing the experiment, right? So you'll do the experiment, you'll get some sort of a value, right? And there'll always be some sort of a value that will be given, right? Or you can just think of as from the Ohm's law. So you will calculate. So Ohm's law you can just think of as some form of a linear model, right? Where you calculate, you will get voltage. If a voltage in the current across the conductor has been given, you'll calculate the resistance, right? So from that Ohm's law, from that formula, or from that linear model, you will get some sort of a resistance. And then while doing the experiment also, you'll get some sort of a resistance. Both will not always be same. Okay. So there will be some sort of a deviation or some sort of an error from the actual value. So the linear model that you are doing. So the linear model you can just think of as some model that has been developed, or that has been from some that has been developed, right? So V equals to IR. There might be some sort of ambiguity, but we generally deal that Ohm's law as V equals to IR, right? So that you can just think of as some sort of a linear model. Here also, many a times in ML model, when you will deal with the linear regression, so just leave those things. As of now, you can just think of as you have been given some sort of a actual data, and you have built a model like V equals to IR, some sort of a linear model. So both the actual data and the value that you will be calculating from your model that you have made, okay, or linear equation that has been given to you, and the actual data, there will be some sort of a deviation. Okay, that deviation you call it as an error, and then you square those error or the deviation that you are getting from the actual data and the experimented or the predicted. So whenever I'm saying the experimental data or the predicted data, that is those data that has been manufactured from some of the linear equation. And actual data means that's the raw data that has been given to us. Okay, so there is some deviation from the actual data to the predicted data. Those deviation you call it as an error, and then you square those error and then calculate the sum. There is the reason behind doing this square also for those errors. If you want to understand this, so basically what happens whenever you're dealing with the ML model, so there are so many metrics to check whether the model that you have created is good or not. Okay, so one sort of error metric is this sum of squared error. Maybe some of you who have not heard of the ML model and all, that can be alien to you, but as of now you can just think of as there is some data has been given to you, actual data, and some data that you are manufacturing from the linear equation that has been given to you, and whatever the deviation that you are calculating, right, that you call it as an error, and then you square it and then do the summation. I'm just telling you why do we do the square. Okay, if you are not able to understand this, that is also totally fine as of now. Why are we doing the square of that? Because you have to check whether the model or the linear equation that you have got is good or not, how much deviated that is from the original data. Okay, let's for example I have not squared. Okay, if I'll not square, what will happen is many a times, if let's for example y equals to mx plus c is the equation that I have built, so this is a model 1 or linear model 1. Okay, and I have to check whether this y that I'm getting, whether how deflected, how like there is a variance, okay, from the actual data. And if I will just calculate this, for example y, okay, so this will, I'll get it as 5. The difference, let's for example the difference that I'll be getting, so y equals to 5, but from the data set I should have got 4. Similarly, okay, and this is y1. Similarly, I will calculate y2. I should have got 6, but the actual data set, this would have been 7. Okay, if I'll calculate the difference, I'll get it as what? From here I'm getting 1, and from here I'm getting -1. Correct? And then if we'll just add it, I'll get it as 0. Correct? If I would not have done the squared, I will just have done the sum. Okay, then in the end, if I'm getting 0, that means what? This will tell that whatever the predicted value that I was getting and the actual data, there was no deviation. Okay, that means what? This model is pretty good. But this is not, because see, from one point I am just getting +1 and from the other -1, and in the end while doing the summation we are getting 0. Okay, so that's why we are trying to do the squared form, so that the error that we are getting, that will get squared up. Okay, so whatever, if there is a less error, if the less values are there, you already know that if there is some value that is less, the square also will be less. Okay, so that means whatever the error that you are getting from the model, that will be pretty, like if you're doing the square also, in the end, whenever we'll do the summation, that can give you a comparative study. I hope, I don't know whether how many of you are able to understand this. Okay, but as of now, because you have not dealt with the ML model, so I'm just telling you a broader perspective of that. Okay, if you have not understood, okay, that is totally fine, because you'll be learning all this concept in the later ML courses. As of now, this is just like a metric. You can just think of as one of the metric that you use it to calculate the error from the actual data set. Okay, I'll just give you an example. If you are able to understand, that is totally fine. If you're not, then also it's fine. You'll be learning in the coming courses and all. Okay. How many of you have understood this? Whatever I said, why do we square it and why don't? Okay, so many of you have understood. Okay, many of you have understood. It's totally fine. But if you have not understood also, that is also because it's now, as of now, to understand this, it's pretty difficult. I'm done dealing with one example. Let's, for example, you have built a model and you got the linear equation as y equals to 2x plus 2. This is the model that with the given x, you will be calculating the predicted value y. This is your model. So let's, for example, this is M1. Okay, this some sort of, let's for example, you just think of as a Ohm's law also. You can just consider it as Ohm's law with biasness of 2. Okay, Ohm's law also is some form of a linear equation. Here also you can just think of as this is a linear equation. Whenever I'll put the value of x, I'll get the value of y. Correct? This is a form of a linear equation. It's a straight line, right? And the actual data has been given to me as like this, x and y. Whenever x is equals to 1, I should be getting 5. Whenever the x is 2, I should be getting 6. If x equals to 4, I should be getting 9. And if x equals to 9, I should be getting 18. This is the actual data. Okay, this has been already been given to you. Okay, so this is the actual data. You can just think of as actual data. This data, if I'll put some x value, whatever that y that I'll be getting, that is the predicted, or from the experiment I'm getting. Okay. So this, let's for example, if I'll put, so this is the predicted data that I'll be getting. Okay. So for me, let's for example, I just write it as y cap, or not y cap, or y predicted. Okay, as compared to x. So if I'll put x equals to 1, what will I get? If I'll put x equals to 1 here, I'll be getting 4. But that is not same as the actual data, because this model I have built, this model, the value that I'll be getting yi or yp can be different from the actual data. And that is what happens many a times when you do the experiment. You don't get the, normally you don't get the same value, right, from the Ohm's law that you should be getting and the actual value, while the raw data that, like, you do the experiment, whatever the resistance you get it for the conductor, you don't get it as same as what you get, what you are getting from the Ohm's law. That can be different, and that is what you mean as a error is, right? So here also, from the Ohm's law, you can just think of as this is the Ohm's law. From here, you are getting, whenever you are putting x equals to 1, right, you are getting the potential, like the resistance, or y equals to 4. Similarly, when you will put x equals to 2, right, you will be getting what as 6. That is exactly same. So many times we can get same also. There's no problem in that. Whenever you are putting x equals to 3, sorry, x equals to 4, you'll put it as 4, you'll be getting from predicted as 10. And whenever you'll put it as 9, you'll be getting as 20. Now, the second thing that I told you was to calculate the error. So we have calculated the error. Now, how will you calculate the error? So the given, this is the predicted value, this is the actual. The actual is what? 5, 6, 9, and 18. Now you have to calculate what the error between these two. So you can just calculate it as yp minus ya, or ya minus yp. That is not going to make a difference, because in the end you are going to do the square of that. So you do the square of minus 2, or you do the square of 2. You are getting the same value. Okay. So yp minus ya is equals to minus 1. Here you'll be getting 0, here you'll be getting 1, and here we'll be getting 2. Now, what I was saying is, why are we doing the square? We are doing the square because, yeah. So just a second, I just getting a call. So yeah. So why I'm doing a square is, see, if you just add these two, you are getting 2 here. Okay. Many a times you can have a model M2 that will give you 1 only. Okay. So there, the comparison that you'll be making, if you're just adding the exact value, right, that cannot give you the best idea about the model. But whenever you do the square of this, right, so that means what? 1. Here also you do the square, you'll get 1. And here we're doing the square, you'll be getting 4. So here, if you'll do the summation of this 4, you are getting 6. Correct? That means what? You are getting an idea that this 6 is some sort of a unit. You can just think of as the 6 sort of a unit. This model is varying from the actual data. Are you getting me? So if you have been asked to calculate the sum of square error, this is what you will calculate. So for this question, the sum of square error is 6. So you have calculated the error. You do the square of that and then do the summation of all those things. Okay, you'll get it as 6 as a value. Okay, I hope it is somewhat, it will have made it clear to you. Okay, I'm getting a call. Just give me a second. Yeah. Yeah, can you hear me? Oh. Yeah, so okay, so that was the concept of SSC. If you have a doubt, you can just let me know. Anywhere, if you have any doubt, you can. Yeah, so for any sources for extra problems, right? We have a lot of problems already in the, if you just go through the activity question, practice questions, and then graded. Apart from that, if you need, we have a book also, so that also you can refer, okay? So that will be there in the supplementary content, so you can just refer that book also. So why can't we use, just take mod? Okay, so see, that is what I was saying. There are a very large number of metric, okay, to check whether which model is good. Let's, for example, I was dealing with y equals to 2x plus 2. Let's, for example, you just come up with a model 2x plus 1, and then we can calculate which model is good one, whether your model predicts good or which my model predicts good. And how do we check that? There can be n number of metric. Maybe that metric that we are dealing with, that is what is error that we are calculating, then square and then summation. There can be a metric that will take the square root also. In the end, that can take a square root. So that will be what? Square root of whatever the summation squared of that error. That can be another metric. The other metric can be mod of value. You just calculate the error and take the mod of those two. That can also be a one of the metric. Okay, or you directly do the summation. That can be a metric. That can be a bad. That is a very bad metric, but that is also a metric. Okay, so you can have n number of metrics. So the mod one that somebody is suggesting, that is also one of the metric that we generally use it in MN model. But here we are just dealing with one out of those metrics, that is sum of squared error. So that is what I was saying. There can be n number of metric to check whether which linear model that you are building is good. But here we are just dealing with one model, that is sum of square error. In ML courses, you will come to know that there are n number of models that you check. Okay. I hope this would have helped you to understand. Okay. Yeah. Yeah, my board is not visible because that there's some error that has happened. Okay. Any other doubt? So I will try to uh, tell you like without writing itself. If you have any other doubt, any conceptual doubt that you have, you can just let me know. You can type it in the chat box. I'll just try to make you convinced. Yeah. Maybe in the next session. Yeah. So we'll try to. Yeah, there is some error because of the rain and all. So even that's why there is some issue that has happened today. But I don't think so that will repeat it. Okay, any other doubt that you have? So we have dealt with week one has already been done. Week two also has been done. So maybe we'll have one more session. Maybe tomorrow, or day after that. I'll let you know when is that session, and then we'll cover all the doubts that you have, like doubts related to any of the questions from the practice assignment or activity questions and all those type of things. And tomorrow you'll be having a TA session also, so you can come up with all your doubt in that session also. So the timing will be 4 to 6. Okay. So that session also you can join it for your doubt. Okay. So tomorrow you have a 4 to 6 session. Day after that also you'll be having 4 to 6 session. So yeah. So from tomorrow you'll be having evening to 4 to 6 also. So Wednesday, Thursday, and Saturday. Like you'll be having 4 sessions. One is Wednesday, one is Saturday, Sunday, all 4 to 6. One more day I'll check which one is the. So 3 or 4 sessions will be taken by the TA, and will be like we will be taking, me or Samiksha will be taking 2 or 3 sessions per week. Okay, so this is how we'll be covering. We'll be covering the summary plus the conceptual whatever you're having. Okay, so tomorrow you can join it as 4 to 6 to discuss all your doubts that you have from week 1 and 2. Okay, I hope this is clear to everyone. So the book, if you can find the book in the supplementary content, okay, you'll be having one books section itself, okay, that you can find it. Yeah, injective, subjective, everything will be dealing in the week 5. Okay, so you don't have to worry much about that. As of now, you can just deal with what is domain, codomain, and all those basic stuffs only. Yeah, will not be asking much difficult portion till week 4. Week 5 again, mostly from week 5 will be just be dealing with the function itself, injective, surjective, all those type of one on two. Every function will be dealing with how to check whether what are the horizontal tests, what are the vertical tests. So all those things will be dealing with. Okay. Yeah, SSC topic is already there. Yeah, I mean, don't worry about that. Non, so there are so many people who has done like very nicely, like even though they were not from the math background. So you don't have to worry. We'll just be starting from we are just starting from very basics, right? Many of the people are not from maths background here. Okay, so you don't have to worry. How you don't have to order book. You'll be getting the book here itself. So getting the book means the not the hard copy, the soft copy itself. So on the portal, the supplementary content. Okay. Now, if it's not there, I'll check. I'll check and then I'll upload it. If it's not there, I'll also check from my side, yeah, and then it will be uploaded by tomorrow if it's not there. But most probably it will be there, but then also I'll check it. Okay. So yeah, from the foundation, you just finish the foundation, and then you'll be having a lot of ML courses and all. Yeah. So tomorrow 4 to 6 you have a session. You can just come up with all your doubts that you have. We'll be discussing the doubts. So TA will be there. He'll discuss all your doubts there. Okay. I hope, yeah. So we are done for today. Maybe we'll meet tomorrow. Like tomorrow, so you have 4 to 6. Even Saturday you'll be having. So Saturday evening we'll be meeting and we'll start with whatever the yeah. So in the supplementary, okay, it's not there. Okay, it's fine. I'll upload it. So somebody has shared the screenshot. Daman has shared the screenshot. It's fine. If it's not there, I'll just upload it after the session. Okay. Yeah. So yeah, 11th is the deadline to submit it. Yeah. Tomorrow is the deadline to submit that. I hope this session would have helped you in some or other way. So week 2 we are almost done. Now we'll just solve the problems and all. Maybe tomorrow 4 to 6, you just come up with all your doubts. That session we can extend it also. If you have a more doubt, we can just extend this session for 3 hours or even more. Okay. So it's fine. You just come up with all your doubts tomorrow. Try to solve each and everything. If week 1, I guess the deadline is tomorrow, try to deal with all those. We will not solve the graded assignment, but we can solve all this practice assignment or any conceptual that. Even we can give you the hint about the graded, but will not be solving it. I hope this is making sense. So yeah. Okay. Okay, so can I close the session? We'll meet tomorrow to discuss your doubts, whatever that doubt that you have. Okay, everyone. So have a good night and bye. Okay, thanks. Thanks everyone and good night.